Good morning, Algebra 2 honor students, ladies and gentlemen, jury, judge. Anyway, yeah, let's try to be funny. At least I didn't say executioner. Oops, I said executioner. Anyway, you laugh good. Thank you for laughing. Okay, here we have. We're all right, here we have 18, match each graph with function. And so really it should be pretty easy to do if you know what the vertex is, right? The vertex tells you what it is, and I'm just going to look at A here. So we have a vertex here at the point that looks like that's 6. -4, is that what that looks like, the vertex?
Yeah.
So which one of these is going to be 6, -4?
Second one.
You think this one here?
Yeah. Here I'm saying.
Okay,
Wait. -4?
Yes.
Oh wait, they all have their own equation.
yeah, and then you can test them on your calculator too, right?
Yeah.
Yeah, you can test on your
I
calculator.
was coming for
All right, thank you, Marcus. Appreciate that, Marcus. Everybody agree with Marcus on this one? Yeah.
We love Marcus. X.
And then this next one here, I guess we have 6, 4.
Yeah.
So which is this one going to be?
Last one.
This will be the easiest one of them all, really. So that's going to be B, right?
Oh, I did not.
B. And then by process of elimination, this one better be it, right?
C. Hope so.
I hope so. Let's just check to make sure, because we got plus, that's to the left, and down, yeah, that checks. That's going to be -6, comma -4.
I didn't read.
Okay, so really a pretty easy exercise, but we're at the end of the section, so we're sort of summing up a little bit here, right? And plus, we've done this after yesterday, so it should be a little bit of a review. Thank you all. Marcus, everybody else. All right. Here we are with 19, explain the error. Can you explain the error for 19?
Yeah.
Siggy says yes.
The vertex should be, yeah, the vertex, it should be -3.
Giggle said yeah.
Okay, so Siggy says the vertex,
Like
so it should be,
equation.
should be. Siggy, tell me. So Siggy says equation
X.
should be
X
y equals, do you say here this one -3?
Yup.
But the +2 is right, isn't it?
Yup.
Okay, so this will be our answer.
Yeah.
Number 19. So we're finished with this today. It took a few minutes. Now we're going to do from now the rest of the day. We're going to be working on notes on solving absolute value equations. So we're going to be doing that. So you can hand this in.
Pick it up.
Yeah, so you can pick it up for us. I appreciate it. Thank you.
Yeah, I'm sure we got crumbled.
So funny. Who's funny?
Give her a kiss while you're there, Ziggy.
I'm graciosa.
Give her a kiss while you're there.
Wait.
I've never kissed someone before.
What's today? 22nd?
I don't know how to kiss anyone.
Excuse me? No, your birthday's tomorrow.
Yeah,
Like
but
a-
I'm gonna kiss
Kiss Jason.
Thanks.
It's
Wait,
kissing guys for it.
So tell me,
you step all over my watch. You step all over my watch.
I guess we'll talk about birthday tomorrow. There's time for birthday tomorrow.
Oh yeah, my birthday.
My birthday's
Your
My
birthday?
birthday's
My
tomorrow.
birthday's tomorrow.
I counted.
All right.
Nobody knows my birthday.
Okay. Thank you. All right. Thank you, everybody. Okay.
You know my birthday? Ellie, you know my birthday?
All right.
Yeah.
Let's bring it back. Bring it back.
Bring it back.
bring it back,
Ain't that a dance?
discussions of birthdays. We can wait for those tomorrow, right? Okay, thank you. Thank you, Kendall, everybody else. All right.
Next year.
All right. Here we are solving absolute value equations. This is section 2.2. And we have an essential question: how can you solve an absolute value equation?
Put in your calculator.
Well, pardon me, put in the calculator? Yeah, so that's part of it. So as usual, there are going to be multiple opportunities and ways of solving what absolute value equations are. What happened here?
Who's that with the red shoes? Huh? Who's with the red shoes? Red shoes? That's him.
Something happened to my pen here. Let's see if I can get it to work now.
There it goes. Did it stop working?
Yeah, it did. I went into like a different mode somehow.
Oh no. Come on.
Come to life, come to life, come to life. It is to life. Thank you.
Yes.
All right.
Lives.
Okay.
Is it second? Shut up.
Are we okay now? All right. Okay. The first thing we're going to look at is something Marcus did mention, whether intentionally or not, solving graphically. But we're going to actually solve graphically without a calculator first, and then we're going to proceed. And always, if you have a calculator in hand, like you have, Bryce, can you use that calculator to check your work?
Yes.
Yes, Bryce? No?
Yes.
Yes, Bryce? Yes, thank you, Bryce.
All right.
Okay, absolute value equations differ from linear equations in that they may have two solutions. And this is indicated with a disjunction. I'm not going to hold you accountable for this word here. And that's a statement by connecting two other statements with the word or. So that's why there can be two solutions, this or that. Okay, so we have our first example problem here. Solve the equation, and we have 2 times absolute value of quantity x minus 5 minus 4 equals 2. And so what we're going to do is we're going to graph 2 equations on the grid, and this is what we did in the last section, 2.1, where we plot the function f of x equals 2 times quantity absolute value x minus 5 minus 4 on the grid, then plot the function g of x equals 2 as a horizontal line on the same grid. And so how do we plot this first function here, which is really the left side of the equation? So you're treating each side of the equation as a function, essentially. Do you see what that is doing? Okay. So let's go ahead and take this. Are you having trouble seeing this? Do I need to make it a little larger?
A
little bit larger, I can do that. Okay, that's a little better. So anyway, we're going to plot this function on the grid. So how are we going to plot this function here?
5, negative 4.
So Marcus says if we plot 5 comma negative 4, that would help us find our, what do we call this? Vertex. So 5, these go by 2, right?
Yes.
So 5, negative 4.
Okay.
So that would be our vertex right here. And then we say, and then how do we plot the rest of this equation here? Okay, what is going to be our slope? 2 when x is what?
0.
Greater than or equal to?
2.
What is our vertex?
Oh. Negative.
What is our vertex? 5. Thank you, Lexi.
5.
And negative 2 when x is what? Less than 5.
Yeah.
And so we can just go and do this. Let's see. 1. We can just count grid marks, right?
Yeah.
1, 2, 3, 4. Or we count 2, right? It's 2 to 1. So how about 1, 2, and 1 like this? Would that work?
Yeah.
Yeah, so something like this. Okay, so it's going to go like this. And then -2 for less than 5, so we're going to go like this. Something like this. Okay, and I'm gonna try to. So anyway, that's going to be good. So anyway, we've graphed this one function right here. So this is it. I'm going to just arrow over to here. So it's this thing right here, and this is what we call f of x. Okay, I'm gonna color code with the blue. And then the function g of x equals 2 is a horizontal line on the same grid. So I take this g of x equals 2, so where do we do that? Right here, right? So this is going to be g of x is equal to 2. And then, how do we determine the solutions of our equation here? We take a look where? Where do we identify our solutions to our equation? Where they intersect, yes, thank you, Cheyenne. And anybody else who said that? So here, right here, I'm going to arrow right over to them. So what are these coordinates here? We got
2 and then.
So we got 2, 2, and then we got 8, 2, right?
Yep.
So which ones represents our solutions here? X values. All right. So you get what's happening here?
Yeah.
Yep. On this? Any questions on this? You need time to write this down a little bit. Looks like some of you are writing down diligently. No, you got it.
I got it in my
Okay.
head.
You got it in your head.
I took a picture.
Took a picture.
Yeah.
You have photographic memory, Siggy?
Yeah.
All right. I don't know how, like, have you ever done like a learning style inventory on how you best learn?
Yes.
Yes.
You have? Most people are predominantly visual learners. Did you find that to be the case?
Yes.
You haven't? Are you an audio learner? What are you? A kinesthetic learner?
She's hands-on.
Hands-on, that's a kinesthetic learner. But what it is, it's not, none of these things is hard and fast, right? We are all compilations of different learning styles, but predominantly visual, and that's the reason a lot of times classroom instruction devolves. Is anybody identified more as an audio learner? You do? Oh, okay. So for audio learner, which is like my daughter is really smart at math and a lot of other stuff. But she's an audio learner. This doesn't, it's going to be the words and sometimes the songs and the different things like that. So, but that's really powerful. That's a really powerful ability if you have that, in that you're going to be able to mentally visualize what's going on independent of the graphics a lot of times. Do you find that to be the case? So that's good. Okay. All right. Any questions on this? Okay. Here we have reflect. I don't really like these, but why might you expect most absolute value equations to have 2 solutions? Why not 3 or 4? Yeah, because if you look back at here, is there going to be ever any opportunity for there to be 3 or 4 solutions to this? No. Okay, and so most of the time you're going to have 2 solutions. Are you always going to have 2 solutions?
No.
Is it then 2? Is it possible for an absolute value equation to have no solutions or 1 solution? If so, what would each look like graphically?
No solution. It goes like 100.
Yeah, let me show you here. And what we're going to do is I'm going to go back to our drawing here. Now, what Siggy said is, what if we take this line and make it like, instead, g of x equals -8? How many solutions would we have? We'd have no solutions, okay? And what if we had g of x equals -4? How many solutions would we have? 1. Okay, so this brings us to the conclusion that we can have no solutions, 1 solution, or 2 solutions. Just because the way problems work, you're probably going to see 2 solutions most of the time, just because it's more interesting. But sometimes you'll have no solutions, or on a rare, you'll have 1 solution. So it's something to watch out for. Okay, solving algebraically. So now we're getting away from the graphing. We're going to go to the symbology, the algebra, the analysis for this. And what we have is an absolute value equation, and we're just going to show by some examples. What you're going to usually have is x. If you have the absolute value of x equals a, where a is a positive number, then you're going to have x equals a, or x equals -a. And then we're going to use this principle in solving absolute value equations. All right? Yeah, if you're taking notes, probably your notes to take on this page are this thing right here, this line right here. I wouldn't go any farther than that taking notes, okay? While you are taking notes on this, I do want to mention that I did place a t-shirt order last night.
Nice. Let's go.
Yeah, so I'm not sure. Pardon? Oh, probably when the shirts come, something like that. We'll see. I'm not 100% sure how much they're going to cost yet. I'm thinking $10, but could be actually less.
Yeah.
All right.
That's what I'll be charging.
Let's go on to this one here. Solve algebraically. And here they give an example. And here you have absolute value of 3x plus 2 equals 8. And the first thing to do is you want to isolate your absolute value expression. And you do that by, in this case, subtracting 2. And so you subtract 2 from both sides, you have absolute value of 3x equals 6. And so you're going to rewrite as 2 equations, 3x equals 6 or 3x equals -6. And then for each equation you solve for x. So you have x equals 2 or x equals -2. And then on a number line, you would just mark them in like this. Okay? So that's how they appear on the number line, to demonstrate graphically where they are. Okay? And we're going to go over some examples here today, shortly. Okay. Now, what we're going to do for this one here is just kind of go over this together and fill in the blanks. Then after this, I'm going to have you work independently a little bit. So we're kind of working on this together. We have 3 times the absolute value quantity, 4x minus 5 minus 2 equals 19. And so what are we doing first? Adding 2 to both sides of the equation. So what do we have over here? 21, right? And then divide both sides by 3. And so we divide the left side by 3, divide the right side by 3. What do we have? 7. And so now we do the OR, rewriting as 2 equations. So we have 4x minus 5 equals
2.
Okay, let's look over here. rewrite as two equations, equals 6 or negative 6. So 7 or negative 7. Does that make sense?
Yeah.
Okay, so we add 4 to both sides of these equations, so we get 7 plus 5.
Add 5.
7 plus 5.
13. Or no, 12.
7 plus 5, 12, come on. I don't want to have to flunk you back to 3rd grade math. All right. Okay, and now we have negative 7 plus 5. Negative 2, thank you. So now we're going to just divide by 4. So we have x equals 3. And then we divide negative 2 by 4.
Half.
So we get, so we get negative 2/4 equals negative 1/2. So we can mark these on a number line. So here we have negative 1/2 and at 3. And this one here, from the graphics, it's not clear, but this is negative 1/2. Okay? Questions on this?
No.
Okay, let's go ahead. And I'm going to go to the independent practice on this. Your turn. Here we have a couple equations, so go work number 3 out.
Oh, got you. I'm so.
And we'll review it here in just a minute. Finished with it? Yeah, first one. Finished with the first one. Did everybody finish with the first one?
Yeah. Yep.
Jose, you finished with it? Okay. You're working on the second one maybe?
Yep.
So here, what would you do on this?
Divide by half.
I would multiply by 2. So we would get absolute value of x plus 2
Yeah.
is equal to 20. Is that right?
Mm-hmm.
And so for that I'd get, was it x, correct me if I'm wrong here, I got x plus 2 equals 20.
Mm-hmm.
And also x plus 2 equals negative 20.
Yeah.
And subtract 2 from both sides, so I get subtracting 2, x equals 18.
Mm-hmm.
And here x equals negative 22, is that right?
Yeah.
And so we just, marking on the number line here, let's see, these are all 4 apart, aren't they?
Mm-hmm.
So I would mark negative 22 right here. That's negative 22. And 18 would be like right here. Okay? Okay, everybody was okay on that?
Yep.
Okay, now on number 4, if you go ahead and do that one, 2. Okay, on this one here, can someone help me through the steps? I don't know, Kendall, Atlee, can you help me with the steps
Yeah.
on this?
First
Go
you're
ahead.
gonna subtract both sides by 5.
So subtracting 5 from both sides like this.
Yep.
So you're gonna get negative 2, you got 3x minus 6. And this is gonna be on the right side,
Negative 4.
negative 4.
And then you divide by negative 2.
Divide by negative 2. So that goes away, is that right, Atlee?
Mm-hmm.
And so we get this, and that's going to be 2. Okay, so now what do we have?
Then you subtract, well, then you write it to the other side, to 3x minus 6 equals negative 2.
Atlee.
And so negative 2, and then also equals 2, right?
Yeah.
So 2 and negative 2, and then now it's a matter of what next?
Plus 6 on
Plus 6, plus 6, and we know we're going to have to add 6 over here too, right? And so boom, boom, 3x equals
4.
Yeah.
4, so x is equal to 4 over 3, and over here we have 3x is equal to 8, and so x is equal to 8 over 3. Now we just have to mark this on a number line. Let's see, that's 0, 2/3, that has to be 4/3, right? Is that 4/3 right there? Yeah, this is 2, let's see, 4/3, 6/3, 8/3, right? So is that it?
Yeah.
All right, thank you, Atlee and Marcus and everybody else. Marcus help. Okay, now last thing we're going to look at is here today is fewer than 2 solutions, and we've conceptually talked about that earlier, right? Where we know that that's going to be a possibility for us, and so we're giving an example where you go through the situation. And what happens whenever you arrive at a situation where you have an absolute value of something equals a negative number, that's dun dun dun, no solution, right?
Yep.
Because can you have the absolute value of anything equal a negative number?
No.
No. So that's just, by definition, no solution. And if you want to do that, if I ever hear you going dun dun dun, I'll know that's what you're encountering, right?
Yeah. Yeah.
So no solution. Next, and here we're given an example really quickly.
Yeah.
If we add example B, if you add 3 to both sides, you get equal to 0 over here.
Yeah.
And what happens if you multiply both sides by 3/5 or by 5/3? You get the same, right?
0.
So you'll still get 0. And then if you go ahead and add 4, you get 2x equals 2x minus 4 equals 0, right? Because it's going to be either one. You don't have, because you have 2x minus 4 is equal to 0, or 2x minus 4 is equal to negative 0. What's negative 0?
Nothing.
It's 0, right? So this is a situation where you have 2x equals 4, so x is equal to 2. And because you came up with this thing right here, this is when you knew you only had how many solutions? 1.
Right.
Okay?
Got it.
Because until you came up with this kind of thing here, you weren't sure really. Okay. And so we have a couple of problems I want you to write here on this. I think one of them's going to have no solutions and one of them's going to have one solution. So I'll just leave it, I'll let you work on those and we'll just leave it. I'm going to turn off our camera, all right?
Okay.
Yep.